So the next topic here is some orthonormality condition, and we have here some proof, that is L I k and L j k, that is equals to del of I j, and that is equals to L k I and L k j. So we have to prove this thing, like we have to prove this condition that L I k and L j k, that is equals to del of I j, that is equals to L k I and L k j. So this is the condition, orthonormality condition we are going to prove here. So for this, we know that here I'm writing the definition of the direction cosine, that E j dash, that is equals to L j I and E I. We discussed this result in our early videos, that E j dash, that is equals to L j I and E I. This is the journal form, and I can write it in the form, like I can write it as E j dash, that is equals to L j k E k, like this. Now further is I am taking the dot product with EI dash. So this equation becomes EI dash into EJ dash, that is equals to LJK EK into EI dash, like this. And this is basically the definition of LJK. So LIK. So I can write it as LJK into LIK, like this. And also we know that EI dot EJ dash is also equals to del of IJ. So that means from this equation and from this equation combinedly, I can write it as that LIK LJK, that is equals to del of IJ. So this is the first case here. Now further is in the next step. Now similarly, we know that EJ, that is equals to L IJ EI dash, or I can write it as you can say that EI, that is equals to L KI and L K dash. So I am placing I in the place of the J and K in the place of the I. So I can write this term like this. Now further is repeating these same step. Now I am taking the dot product here with EJ. So we get EI dot EJ, that is equals to L KI, and further is EK dash into EJ, taking the dot product here. So this is again the definition of the L direction cosine. So L KI, that is equals to L KJ, the term here. And this result also we know that EI dot EJ is equals to del of IJ, Kronecker delta. So from this and from this equation, this is called the 3 and this is called the 4. So from these two equations, I can write it as LKI LKJ, that is equals to del IJ. So combining these results, I can write it as that this result is basically LKI and LKJ is equals to del of IJ, and del of IJ is also equals to LIK and LJK. So I am proving this result here, that LIK and LJK is equals to delta. First thing is proof, and the second thing is we prove it here. So this is the proof of this result.